Okay, let's start the lecture. We'll just discuss files and security. So what is a file system? It is a means of organizing information on the computer. So you all know you have different types of files: your Word file, PowerPoint file, text file. So a file system is a computer system for managing the files, how you group files into directories, etc. So it's a logical view, not necessarily a physical view. That is, files are logical. They may be physically implemented by many different disk blocks on the disk. But all you see from the shell is the logical files. So what does the file system provide? So ways to create, move, and remove, delete files, order files, that is to sort, and security. Because Unix is inherently a shared system where multiple users can log on and use the system simultaneously. Therefore, you must implement good security to prevent other people from modifying your sensitive information and vice versa. Unlike Windows, where security is less of a concern because generally only one user uses it, or if multiple users use it, they log on at different times. So example file systems are DOS. DOS is an old file system that predates Windows. Macintosh, CD-ROM, CD read-only memory, where you can only read from it and not write to it, or Unix and NFS. So NFS is network file system, which means that you have a file server that stores all the files. And when you log onto a computer in the lab, you're actually logging onto a client. It's connecting remotely to a server to load up your directories and files. That's why you can log on to any machine in the lab and see the same files in your home directory. It's because the files are not stored locally. They're stored remotely on a remote server connected via NFS. So files are organized hierarchically, like in a tree shape. The root of the tree is the top, denoted as the slash, /. And you may have two kinds of files. One is directories, one is regular files. So directory is really a folder. You call it folder on Windows, but you call it directory on Unix. It's really a legacy name from because the way folders are implemented on Unix is like a phone directory. You look at the directory node, and it contains all the links to the files within it. So that's why it's called a directory. But just remember, it's equivalent to a folder. It's also called directory file because it looks like a file itself. Its organization, its internal structure, it's just like a file, but it's just a special type of file. So directories are branches in the tree, and regular files are leaves in the tree. So here we have a file system with a root directory and a homes directory, which contains corner as a subdirectory or subfolder within it, which contains the three files within the corner subdirectory. So when you log out, you have your home directory. That is the directory you're in when you first log in. This is your space. You control security. Anything within your home directory is under your control. You can change, delete, modify, anything you like. you can put your personalized startup files in your home directory, which is read every time you start your login, so that you can customize your environment, like your paths, etc. Therefore, everyone has their own personalized startup file, so that everyone log in, you can have different settings for your environment. Your working directory, after you type cd, which stands for change directory, with no arguments. If you type cd with arguments, you change to a specific directory. But if you type cd with no arguments, the default directory is the home directory. The working directory is the directory you're in currently. So you can cd to a subdirectory within your home directory, and then that subdirectory becomes your working directory. So to access files in your working directory, you can simply type the file name. Otherwise, to access files in some other directory, you need to type in the full name, or you need to type in the relative path name with directories in front of the file name. But if you don't have any directory names in front of the file name, then you're accessing the files in your own working directory. That is the current directory. So now, to access files in other directories, must use the path name. Path name is a concatenation of directory names and file name. pwd prints the working directory, that is where you are in right now, and cd changes the working directory. You cd to another directory. So there are some shorthands. Dot is the current directory itself. And double dot is the parent directory. That is the one level above you, above dot. And tilde, in most shells, means your home directory. And tilde user means the user's home directory. So say you have a hypothetical user, James Bond, and you can look at his plan file by doing a more or cat to look at. So here's so when I first log in, I see I am in home ZZU. This is my home directory, and I can cd to 111. So now I am in home ZZU 111 directory. So now this is my current directory. And I can go up one level up by cd to dot dot, which is the shorthand for the one level up directory. So, or I can say, suppose I'm in the 111 directory. I can say cd tilde, which means that I go to my home directory. So tilde is shorthand for home directory. Or I can say tilde ZGU. It's the same effect because I am ZGU. Or I can say cd to some other guy's home directory. So now I'm in home's Huamin directory. So the tilde followed by the username is a shorthand for the home directory of that username. So I can look at the other users. Let's see Huamin's .plan file. It doesn't have a plan file, so Yeah. So remember, these are shorthand. You can always type in the full path name instead of the shorthand. So if I say cd homes VGU, I can always go into a particular directory by typing in the full name instead of having the tilde as a shorthand. So slash is the ancestor of all files in the file system. So it's the common root of the entire file system. So I can say cd slash. So now I'm in the very top of the entire file system. I can see a whole bunch of directories here. Where am I? My home directory is in this particular homes directory /ZGU. So this is the top. I go 2 levels down. I can go to my home directory. So /bin and /userbin contain Unix utilities like a cat, which we saw before. So that's what's in bin. A lot of files. Actually, it's too many to see. Let's see. So there are all kinds of bin stands for binary, which means that it's not a human readable text file. It's a binary file that's executable. You can execute it, but you cannot read it. So cat is actually one of the files in here under /bin. So when you type in cat, you're actually invoking this executable file. If you delete this file, that cat command is gone. So actually you can see which cat stands for which. When you invoke cat, which cat is it? You may have multiple binary files called cat in different parts, different positions in your file system. Which one are you invoking? So which tells you which one. And user/userbin contains some other utilities. Def contains files which describe devices, such as terminals and printers. Let's see what's in dev. So you have all these files are not real files. They are actually hardware devices, like different displays. And if you write to these files, it actually writes to the device. So for example, if one file called a printer1 is under this directory, if you write to printer1, it actually prints to it. So it's an abstraction that Unix uses files to hide every other device. So if you add a printer to your system, you add a new file under the dev folder, that dev directory. So etc has administrative programs like password files. etc stands for etc. So miscellaneous administrative things. So if you store password files in etc, wouldn't you be able to see the passwords of other people? Well, the file is there, but it's encrypted. You can only see garbage. So the /temp is for temporary files, periodically deleted. So you see all these files. This is a scratch place. So don't put anything important in here because they will be deleted periodically. So every directory has at least 2 entries. You can barely see it. So .dar is the directory itself, the current directory. $dar is the parent directory. So go back to my home directory. Go to 1111. So now I'm in the home ZG111. I can see what's in it. Too many files. So I can see all these files and directories. But there's another two. One is dot, one is double dot, which is not shown here. So these are implicit. So naming files. Files in the same directory cannot have the same name. But files in different directories can have the same name, obviously. And case sensitive. Big capital case and lowercase letters are different. Secret and big as secret are different. While in Windows, they're the same. In Windows, you may display files in capital and lowercase letters differently. But you try to name a file the same name just with capital case differences, then it'll say it's the same name. So files are sometimes named with an extension like .cpp is a C++ file, .jpg is a JPEG file, a picture file, to show what kind of file it is. But the extensions are used really for the human users and also for the program to know which program to use to open this file. So if you change the extension, it doesn't affect the content of the file. It's just a convention. So it cannot create a file named dot, double dot, because these are special names reserved for current directory and parent directory. Invisible files and directories have a period as the first character. So some programs use invisible files to store information. So in my home directory, I can actually have a invisible.chrc file, which contains all my environment settings in the file. But if you do an LS, so it's in any case, you cannot see the file in LS because it's hidden if you precede the file name with a dot. I think you can see it with ls.a, which stands for list all. Let's page 2 more. So now you can see all the hidden files. Bash history, C shell configuration, and all the hidden files. But if you just type in ls, you wouldn't see them. So path names. So simple file names, that is a file name only without any directory in front of it, can only be used if files in the working directory. But if you want to access files in some other directory, you need to use relative path name or absolute path name. So a relative path name is a string of directory references beginning with the working directory. So for example, here, this guy means that you have a dot slash is the current working directory, and a secret1 is a directory or file within it. So this is equivalent to a simple secret1 without the dot slash. So sometimes you put a dot slash just to emphasize that it is the current directory. And in case it's an executable file, you want to invoke the one under the current working directory. So if it's double dot, it means that go up one level, and then go down to the 007 folder, and then go down to the names file within 007. So you're navigating the tree by going up one level and then down one level. Top 10 LT7 so bad. So this is the top 10 is a folder within the current directory. So this is equivalent to a dot slash top 10, and then slash. So always remember, you can always omit the // in front of the file name because you are in the current working directory. So obviously you can do multiple levels of // means that you go up 2 level and then go down 1 level to the other directory. So a path name beginning at the root is the absolute path name. So that is the say /homes jbond/.plan. That is the it's called absolute because you can type in this path name anywhere you are, regardless of your current working directory, and it will refer to the correct file. But for the relative path names, it's only correct relative to where you are now. So if you cd to another directory, these path names are no longer valid. But absolute path names are always valid. Sometimes you like relative path name because it's shorter. Your absolute path name may be quite long if you start from the root. But absolute path names are always valid. So directory commands make directory makes a new directory if you have the permission to do so. So with a simple path name that is with no other directories in front of your directory name, you just make a new directory in your working directory. You can always use absolute path names or relative path names to create a new directory in some other directory, if you have permission. So suppose you're currently in home jbond/111, you can see three things with 2 files and 1 directory. This guy is a directory because you can see the / after the name. Some systems don't display the /. Some systems do. So having a / here makes it clear that it is a directory. But even more clearly, you can see the D in front of it. This D here indicates that it is a directory. You can say make directory, new dir, and you can see a new directory which is created within the current directory. Remove dir, delete your directory if you have permission. So these pictures mean that you're destroying this thing. So we can remove dir, and now your listage is gone. So how about remove dir /user? Then it tells you directory user search or write permission needed. It's because user/user is a common shared directory for all users. And you don't have permission to remove it. Only the super user, that is the system administrator, have the permission to modify the contents of the folder, of the directory. Move can be used to move a file to another directory. Say, in the current working directory, you have the 4 files here, 2 are real files and 2 are directories. If you say move letter 3 into secret, it moves the file called letter 3 into secret. Now you can see letter 3 is gone from the current working directory. And if you do ls secret, you can see that letter 3 is now in the secret directory. So move can also be used to move a directory into another directory. So say you can say move new dir into secret. Now you only have names and secret here, and now new directory is now under the secret directory. It's a subdirectory under secret. So you can move several files at once. Say, you can say, in the current working directory, you have letter 1, letter 2, we have 2 files. And a folder called secret, a directory called secret. You can remove letter star secret. We'll discuss regular expressions later, but it's a regular expression that refers to any file that starts with the word letter followed by anything, matches this pattern. So you can, after you execute the move, both of these files are moved into a secret directory. So security and access permissions. So there are 3 types of users. One is the owner. That is the user who created this file. One is the group. That is the group that the user belongs to. So I may belong to the faculty group, and you may belong to the student group. And anyone else, that is the other. So there are 3 types of permissions: read, write, and execute. So we'll see. So here's one example. Use ls.l to see the permissions. ls.l means long format. You'll see the long detailed description of all the file information. So let's start from the right. That's the name, letter 3. That's the file name. And then this is the last modification date. This is the size in bytes, 154 bytes. So this is a group. That is what group does the user belong to? So JBond belongs to the CS group. Perhaps you may have other groups like UG student or PG student, etc. Each group may have different permissions associated with it. And number of links, we'll discuss this later. And permissions, which is you have, if you count number of characters in the permission string, you have really 10 characters. So the first one is either a dash or a D. A dash means it's a regular file. A D means that it's a directory, followed by 3 groups. So, okay, first letter is a type, dash regular file, D directory. L means symbolic link. We'll discuss symbolic links later. Now you have the next 9 characters to indicate if the file is readable, writable, or executable for the file owner group or other users respectively. So if you have a dash, it means that it is not, the permission is not granted. So if you have RW dash, it means that you can read it, user can read it, write it, but not execute it. And then followed by R dash dash, it means that the group can read it, but not write or execute it. And other can read it, but not write or execute it. So the 3 characters are RWX. R stands for read, W stands for write, and X stands for execute. So here's the example set of files and their permissions. So say you have this file here called cat, which is an executable file. It is followed by a star, which is the convention in Unix to indicate a file is an executable file. You can run it. and it is r-x for the first 3 characters, which means that the user can read it, not read it, and execute it. And for the group and others, you have the same permissions, r-x. And now, so we'll discuss what execute means for the directories. It's obvious what execute means for a file, just run it. But for directory, it has a different meaning. So directory, if you do ls.l followed by a directory name, what you list is all the files within the directory. Its contents. But sometimes that's not what you want. Sometimes you want to see the directory itself. So you say ls.ld, which means that you want to get information on the directory. Then it displays the directory's permissions, not the the file that it contains. So directory read permission means that you can see what files are in the directory. You can do essentially you can do a ls list all the files. Directory write permission means that you can add, remove, rename files in the directory. That includes the directory itself. You can rename the directory because the directory itself is just a special file within it. It's the dot, right? Directory execute permission means that you can search the directory. That is, you can use the directory name when accessing files inside of it, but you cannot list the content. That is, you can, if you know the file name within the directory, you can go to it, you can see it, but you cannot list all the files to see what is in the directory. So here's one example. So suppose you have the 4 directories under the current directory. You do ls.ld to show all the permissions. So now suppose I'm logged in as jbond, so I'm the user. So my permissions are the first 3 characters here. So for secret, I have read, write, execute permission. For secret 1, I have no permission. For secret 2, I have read permission only, and for secret 3, I have execute permission only. So if I do ls.l secret star, so secret star is this regular expression that matches any name starts with a secret followed by anything. So it matches all the 4 directories. Because I say ls.l not as ls.ld, I want to see what's inside the directories, not the directories themselves. So notice the difference from the ls.ld. So because I have read permission on the directory secret, I can see that you have what's in the secret directory. You have a letter 1 file, perhaps a hidden file. So it says total 2 files. But for secret 1, I don't have read permission, so it says unreadable. I cannot read it. I cannot list the content of the directory. Secret 2, I have read permission, so it says total 0. It means that there's no files in secret 2 directory. And finally, secret 3 is also unreadable. So directory execute permission means that you can cd to it or do ls and cp on individual files in the directory. So here's the same example where we had 4 directories. So secret 1 and 3 do not have read permission on it. You cannot list all the contents within the directory, but you can, if you know the file name, you can say ls.l secret star / letter 1. You know the letter 1. This file is in those directories, so it will show you these files, and you can actually access these files. Because the secret and secret 3, for these 2 directories, you have execute permission. But you cannot do, if you do ls.l secret star, it tells you it's non-readable. But you can get to a particular file with the specific file name if you know the name. So this is very useful if you want your friend to get a file and no one else can. So you can set the directory execute permission to on and read permission to off. Like the secret 3 here has -- execute, which means that cannot read, cannot write, but you can execute. And also it is for the other. Suppose your friend is someone is not in the same group as you, so you set -- execute as the permission for others. And the read permission to the file read permission to on, that is the file inside of the directory, others can read. So you can tell your friend the file name with the complete path. Then your friend can access the file by typing in the exact file name. Others will not know that the file exists. So here's a summary of all the permissions: read, write, and execute. By the way, I modified the slides a little bit, so if you downloaded the slides earlier, you should download it again. So read, write, execute are obvious for files. So if the file can be read or written to or executed. For directories, read means that you can list the directory or not. List the directory contents for LS or not. For write, it means that you can change directory contents by creating new files, deleting new files, etc. For execute, it means that if you can access a directory by CD to it, or do ls and copy on individual files in a directory, provided you know the file name. Changing permissions. So chmod, change mode, stands for change mode, is used to modify the permissions. So chmod can only be used by the owner of a file or directory. So the arguments are, so first you have the file or directory name, and you can say u, which means that you're changing the permission for the user, for the owner. G stands for you're changing permissions for the group as a whole. O stands for you're changing permissions for others. And A stands for you're changing permissions for all, including the U, G, and O. And optionally, one of the characters, like plus means add permission, minus means remove permission, and equal means set permission. And finally, you have combinations of read, write, or execute, RWX. So if you want to let everybody read or write a file, letter 1, you can say chmod plus RW, which means that all add permission read and write letter 1. So you can see all the 3 groups have RW writes to the file letter 1. To allow user to execute the file, you can say schmat u plus x means that give the owner the execute permission. So now you can see you have an x in the user group permissions. Not let other to read the write file, you can say schmat o minus rw. Remove the read and write permissions from the other group, other set of permission bits. So now the others now is dash dash dash, which means that before I had RW dash. Now you removed RW. It's only left with dash dash dash. So to let group only read the file, you can say schmat group equal read. So now the group only has read permission. So notice the difference between plus and equal. For plus, whatever you have permission, what permissions you had before is still there. But for equal, you overwrite all the permissions. So if you say G plus R, then whatever permissions the group has will still be there plus the read permission. But if you say G equal R, then it only has read permission. Nothing else. So there's a shortcut to allow you to use 3 decimal digits to set permissions, where the user is the first digit, group is the second digit, and other is the third digit. So each of the decimal digits represent a 3-digit binary number for read, write, and execute. So, for example, 111 means that the read permission, write permission, and execute permission are all granted. So the binary number 111, if you translate into a decimal, is 7. So 110, which means that read is 1 granted, write is 1 granted, and execute is 0. Execute is not granted. So now it's decimal number 6. Binary read only 100, decimal number 4. So you can say schmat 764, which means that change the user's permissions to 111, that is RWX. Change the group permissions to 110, that is RW dash. So 0 corresponds to a dash. And others to read only to 100, which means R dash dash. So as a result, the permissions are set like this. So it is a shortcut because it's easier than typing in schmat u plus something, o minus something. You can type. You need to type a lot of lines. But if you use the binary mask, it's easier to set the permissions. So another example, if you say schmat 135, what does it mean? It means that user is execute only 001, group is write and execute 011. Others are read and execute 101. So now you have the permission bits like dash dash x, which correspond to 001, dash wx corresponds to 011, and rwx corresponds to 101. So you can always use the schmat plus, minus, or equal to do these changes, but it's easier to use the bit. Use this shortcut. So any questions on this? So let us move on to the next part. So we'll take a break in 5 minutes. So links. A link is a pointer to a file. So you know pointers in C, right? You can have pointer to an object or to another thing. So all file names in Unix are just links to a file. Most files only have one link. So if you do an ARS list all the files, say you have the two files and one directory, this part indicates number of links to it. So additional links to a file allow the file to be shared. So you can access the file with the one link or another link. As long as they point to the same file, you're accessing the same file. So ARN creates new links. So for example, if you say ARN names, big names, it means I created a link called big capital letter names that refers to the same file as the lower letter names. Assuming the lower letter names is the existing file. So now you see the number of links in capital letter names is 2. How the number of links in the small letter names is 2, which means that this particular file has 2 links to it. One is the lowercase, one is the uppercase names. But they point to the same physical file on the disk. And also, after you create the links, these two are symmetric. That is, you don't have one is real file, one is a pointer. Actually, these two are really symmetric. They are all links. So if you remove one, the other one stands as a standalone, is still valid. So the link ARN command creates a new link, not a new file. The new link and the original file name are equivalent pointers to the file. So the last argument is the link destination, which can be a path name of a new regular file, like what we saw before. This means that create a new link called big names that points to the same link as the small names. A path name of the existing directory. Then, if you say ARN names and secret, which is existing directory, you are creating a link with the same name as the original file in the directory. So if you say ARN if you can create a link with capital letter names, or you can say ARN names in secret. So now if you see look inside the secret directory, you can see a file called names, and it's actually a pointer to the same file as the names here. So now you see the 3 as the number of links because you have really three links to the same file. One is the original names, one is the big capital letter names. I created a link to it before. One is the one inside the secret. So we have 3 links now. So, and no second argument means that give a second argument of dot. So if you say Ln secret letter 1 names. Say about this. So essentially, this is equivalent to Ln secret names dot, which means that create a link in the current working directory that points to the file specified in here. So if you happen to already have a file called names in the current directory, then it says file exists. Otherwise, it creates a link for you. So this is just a shorthand for you can omit the last argument if it happens to be the current working directory. Otherwise, you can specify it like this to make it more clear. So questions? Okay, let's take a 8-minute break, and we'll resume at 2 o'clock. Okay, we start talking. So some people are still confused about the execute permission for the directory. So the directory read permission means that you can list the contents of the directory, but execute permission means that you can access a directory. That is, you can access the file within the directory, provided you know the file name. So for this example, if you say ls.l secret 3, you get no read permission error because secret 3 doesn't have read permission for the directory for the user. But if you know the file name within it, you can do ls with the exact file name, and you will see the file inside. So this is really so-called security by obscurity. That is, if you use this method to share files with your friends, and if other people somehow guess the file name, then other people can also access the file. So in Unix, you only have the 3 bits to play with for everyone else, for others. You really cannot fine-tune your permissions to individual users. So you have for yourself, for the owner, for the group, and for others. So therefore, you can only set the permissions for all others. And also notice the permission for the directory and for the file. So whether you can reach this letter 1 file or not is determined by your read permission on the file. So the directory permission allows you to see the file, if it's there or not. And the file permission lets you determine whether you can touch the file, read the file, write the file or not. So you see the difference there? Directory, you can see directory is really a whole bunch of links to files. Right? If you can read the directory, it means that you can enumerate the links. You can see what's inside the directory. But whether you can touch these files or not is another matter. It's determined by the file permissions. So if you can execute a directory, it means that you can search through the links, and you can look at a particular link to see its attributes, like its multiplication date, its size, and its permissions, etc. And then whether you can actually go into the file and see the contents is another matter. So now you can see the directory is really fits its name, right? It's like a telephone book. It contains all the meta information about the files, like a person's address. But the actual person is somewhere else, right? So it's really a whole bunch of collection of links. So we come back to links. So link has two pieces of information: a name and an inode number. Inode is the data structure used to implement files on the disk. So inode number refers to a specific block on the disk. So it's a physical address on the disk. It's an index into a system table that has all the information about the file. So for example, if you have JBON as the directory with the 3 files in it, and this big capital letter names is created as a link to the file called small letter names. In the actual underlying system, what you really have is this system table with this inode number, which is its address, and the user ID, which is the internal ID for the user, group ID, and finally the physical address, which points to the actual file. So the inode ID lets you find this particular file's information in the system table. If you create a link, then both of these files, including the original file and the new link, really are both links pointing to the same entry in the system table. So from here you can see that the original names and the capital letter names, these are equivalent, right? You shouldn't think of the lower letter names as the file and the capital letter names as the pointer. They're both links, they're both pointers. They're both pointing to a particular entry in the system table. So you can say rs-i, which means that see the inode number. You can see this is the inode number used to index into the system table. You can see capital letter names and small letter names are both have the inode number 42979, which is obviously will be different for your particular file. It's just an example. So, and also the number of links are 3, right? Because we created another one under the secret directory, another link. So there are totally 3 links pointing to the same entry with inode number 42979. So using remove actually removes the link. When the last link to a file is removed, the operating system actually removes this file. So that is, when you have 3 here, it means that there are 3 links to the particular system table entry, to the real file. If you remove capital letter names, it drops down to 2. If you remove small letter names, it drops down to 1. If you remove the one inside the secret directory, then it drops down to 0, and then the system removes the file. So it's like a reference counting system. So you count how many references are there to the file. When the reference count drops to 0, you remove the file. So let's play with this. So now you can see you have 3 very easy to see. So you have names. If you remove names, now you have the number of links to a name drop down to 2. If you remove the one inside secret, now the number of links to names, it should drop down to. Did I remove that? Okay. Anyway, so the message is that you remove all the links and then the file is gone. Otherwise, the file is there. So symbolic links, a symbolic link is a pointer to a path name, not a pointer to the file itself. So now this is a real pointer, like in a real sense. It's asymmetric from the file itself. So you say ln.s, which stands for create a symbolic link. If you don't have dash s, like before, it's called a hard link. A symbolic link is also called a soft link. So if you say ln-s names, s names, it means that create a symbolic link called s names that's pointing to the actual names file. If you do ls.li, you can see that S names arrow names. This means that it's a symbolic link, and its inode number is 42916, which is different from the inode number of 42979. So it's a different entry in the system table. And notice it has a different size. It's 5 bytes only. While the original file is 64 bytes, which makes it clear to you that it's just a pointer. It doesn't contain the actual file. As opposed to a hard link, like the big capital letter names, which is also 64 bytes, and also with the same inode number, 42979. So symbolic links are called soft links, and regular links are called hard links. So for directories, you cannot make a hard link to a directory, but you can make a symbolic link to a directory. So if you say ln secret is a directory, secret link, secret h link, then it tells you hard link not. Let's see what happens here. It tells you a secret is a directory, so you cannot create a hard link to it. So different systems have different error messages. So perhaps this system gives you another error message that secret hard link is not allowed. So, but if you can create a soft link -s secret s link. So now you can see secret soft link is a pointer to the secret, and the idle number is this huge number, which is different from the idle number of the secret, the original directory idle number. So here you have two symbolic links, and one has size 6 bytes, one has size 5 bytes, and they're pointing to the actual real files or directories. You can use the soft link just like the real file or directory, because it's CD, secret soft link, and do a PWD, it tells you that you're in the secret directory. So it's like an alias to the real directory name. So also you can delete the symbolic link without affecting the original file or directory. But if you delete the original file directory, the symbolic link is no longer valid. Therefore, it's an asymmetric relationship, unlike the hard link, which is a symmetric relationship. So you can make symbolic links across file systems. So look at, suppose you're in the current directory is jbound/secret, and you look at the /temp, which we discussed earlier. It's a place for storing temporary files. Suppose it has only a single file in it, and you say ln, you want to create a hard link in my current secret directory called ps-data, ps_data, pointing to the same file as the ps_data in the temp directory. Then it tells you that ps-data is on a different file system. But if you can create a symbolic link, -s, and then you can create some soft link in the current working directory, pointing to the other real file. So so you can create soft links across different file systems, but you can only create hard links between files on the same file system. So a different file system, which perhaps means that it's another disk mounted on the system, but it's really managed by a different file system. So even though they all hang underneath the /root directory root, it's really on a different physical file system. So especially temp is a special directory because it's used for temporary storage. Therefore, it often uses a different hard disk, perhaps a local one, to store all the temporary data. as opposed to your home directory, which is a remote directory on the file server connected by NFS. Temp is often a local directory on the local machine to speed up your access, because you're using it to store temporary files. You don't need to save it after you log out, so it's okay to store it on the local directory, local disk. Therefore, your home directory is often different on a different file system than the /temp directory. So there's no way to tell how many symbolic links there are to a file. Unlike the hard links, you can look at the number of references. Number of links is shown if you do ls.l, but for symbolic links, it's not shown. So therefore, you must be careful when you delete a file, because you may break many symbolic links to it. So the most important difference between hard and soft links occur when the link is removed. So here, echo 123 error greater than first. This means that echo 123 produces as output 123, and then it's redirected into the file called first. Remember redirection? This greater than means redirect the output of the command into another file. So this guy creates a file with the content 123 called first. Now, you do arn first second. It means create a hard link called a second, pointing to the same file as first. So if you remove first, so let's see. So now first, after echo is this one small file with the 123 as its content. If you say arn first second, now you see two files. Pointing to the same inode number and with a number of links too. If you remove first, second is still there. You can see second containing the same content as first. So this shows you that the first and second are symmetric. They both point to the same exact content, the exact file. And now you can create a new file which contains a different content, 456. You can see what's in first is 456, and what's in second it is 123. So now the first here is now a completely different file from the previous file called first, with a different inode number. Now let's look at what happens if you try this on a symbolic link. So let's create a file with 123 as its content with a symbolic link. Now you can see we have second is a symbolic link, which indicated by the arrow first, with a different inode number, and both number of links is 1. Now if you remove the first, so now the file first is gone. The link is still there, still pointing to first. If you try to look at this link, it says no such file directory because that the file itself is gone. All you have left is a pointer. So now if you create a new file called first, so now first is a new file. The pointer points to first. You can see the file now points to the new first. So you see what you did here. First you create a file. You create a symbolic link to it. You remove the file. The symbolic link is no longer valid. It's pointing to nowhere. And then you create a new file called first. And this symbolic link becomes valid again. So the reference is by name. Therefore, even if you create a new file, as long as the name is still called FIRST, the link to it is still valid, and the soft link still works. Compare this to a hard link. In this case, where both first and second are symmetric. So even if you remove first, the second is still a valid link to a file. So, and later we'll create a first again. It's a different file. So the lesson is that hard links are symmetric and soft links are asymmetric. Soft links are file and pointer. When the file is gone, the pointer is no longer valid. Any questions? So now we switch a little bit to talk about appending and pattern matching. So we saw our input redirection with the less than symbol. So cat less than file, which means that cat is a command to display a file with the standard input as the keyword. But if you say less than file, it means that redirect the content of the file called FIRE into the command to replace the standard input. You can omit the less than as a convention. And upper redirection means that you place the output into the file instead of displaying it on the display. So if you say greater than double greater than, then it means appending to a file. So if you say date who, now you see who contains the output from the date command. If you say, date file. Now file contains the output of the date command. If you say who file, it will tell you file exists. That is, but if you say who double arrow file, then you append to it instead of overwriting it. So now you have the original content followed by the new content. So pattern matching, we'll see some regular expressions later in detail, but now we see a little bit pattern matching. Star matches a number of characters. you say ls.l letter star, it means that match any file that starts with letter and end with anything. Letter 1, letter 2, letter 4, letter er. So anything that matches the first 6 letters would match this particular pattern. So question mark matches any single character. So the letter question mark will match all files that start with letter followed by exactly one character. So it matches letter 1, letter 2, but not letter 10. Because 10 is two characters. But letter 10 would match letter star. So let us move to the next part about the shell. So you see a chicken coming out of the shell. So the shell is really this user interface. It's a command line user interface, not graphical user interface like what you are familiar with on Windows. So you type in the command. So with a bunch of options and arguments, name if the command is first. Options are normally single letters that turn an option on and off. They can be combined or given separately. So if you say ls -l means long formats will display detailed information. -d means display the directory information. -i means display the inode information. Or you can say ls.dir without any spaces. It means the same thing as ls separate -l-d-i. So options sometimes can take a value. The value can be either given right after the option or separately. So this is the ypcat command, which is a yellow page lookup command, which is not really used nowadays. It's really an old command. With a -d option with argument after -d as the value for the argument. So most commands require you to give all options before file name arguments. So anyway, that is you should put -n before the names. If you put it after names, then most systems will give you an error message. So it will view the -n as another file called -n, which is not what you intended. So it says cat not open -n. But if you put it before the file name, it should give you the line numbers 1, 2, 3 in addition to the file contents. But if you say cat names -n, then it doesn't recognize the option. It thinks that -n is another file. So spaces separate to options. To turn something with spaces into a single argument, use quotes. So suppose you have letter 1, which contains this sentence called you have this Florida boat thing And grep is this command that finds a pattern within the file. So it returns the line in the file containing this thing pattern. But what if you want to look for this combination of both things? So it says grep both thing letter 1. So you may think what you want is really to grep for both thing within the file letter 1, but the shell thinks what you're trying to do is to grep for both within the file called thing and in the file called letter 1. So it finds the both word in the letter 1 file but not in the thing file, because the file called thing doesn't exist. So what you really want is surround it in quotes. Now the shell, it understands your intent. Now you're trying to grep for both thing, the whole group within the file called letter 1. The double quotes or single quotes are a little bit different. We'll discuss the differences later, but for now, you can use them interchangeably. When we discuss shell programming, the double quotes and single quotes are different. But up to now, we haven't touched programming issues. So slash is the escape. So suppose you have a letter 2 called containing this sentence will tidy up a few things. Now you want to try to grep will. So what happens is that this single quote here is special. So the shell thinks you're trying to enclose it, enclose some group of words in it. So it's looking for a matching single quote. It cannot find it. It's unmatched single quote. But you can escape it by typing in \. This means that don't treat the single quote as special. Treat it as a regular character and match these 5 characters we single quote LL at the single group within letter 2. Now it finds will tidy up a few things to find the sentence. So, and also if you say echo star, it means that echo all the file names within the current directory. But if you escape it, this means that treat it as a regular character and just echo this character back to me. So it gives you back a single star. So slash is an escape character. So how does the shell find the command? So if you type in a command like cat or ls, where is it? So the shell searches a list of directories for an executable file with the same name. So which list of directories? It is determined by, if you're using Bourne shell, it is in the capital letter P path variable. And if you're using C shell or TC shell, it is in the lower letter path, which is an array of variables. So in the Bourne shell, you have capital letter path, which is a single variable separated with different paths separated by colon. But in C shell and TC shell, you have an array of variables with parentheses. So, but you can specify the same path, same set of paths with different syntax in different shells. So if there's a match in more than one directory, the shell uses the first one it finds. Which is the first one? Well, is typically searched from left to right. So if you have the same executable file in the bin, use the local bin directory, another one in the later directory, then it uses the first one. If you want to run a command that's not in one of the directories, you can specify the full path name, either relative or absolute. So suppose you have the executable called CSC sound under user corner /bin, and this guy, because corner /bin is not in your path, you cannot simply type CSC sound. Instead, you must specify the entire path name to get to the executable, to get to the command. So specifying a path, a variable or a path array allows you to save a lot of typing. If you store your executables in different places in your home directory, you can specify all the paths, so you can type in the file name, command name, instead of the whole path name to get to the command. So a few commands are built into the shell. That is, it is not executable stored in one of the directories. It is inside of the shell. That is, the shell itself contains it. You may never find executable. So for example, echo. So echo is built in for efficiency because if you have executable file in the directory, you need to search all the directories in your path, which can be a very long list, and it may not be very efficient. But if you have a built-in command, then you don't have to search the path anymore. So it's more efficient. So you can find out where the shell is getting a particular command with the which command. So it's a which echo. It says which echo command are you running. So it tells you echo is a built-in command, and it just asks which cat. Cat is executable within the /bin directory. Which grep is also in /bin. Which RS is user UCB/RS. So it's a UC Berkeley produced list of commands. So alias, so the C# has the alias command, which allows you to create command shortcuts. So, so if you say alias rs double quote rs-f, it means that you're creating an alias called rs, which is really, when you type in rs, you're really executing rs-f. Or you can say plus as alias for shmod u plus x star. This means that you are changing the permission of all the files in the current working directory to give the user, the owner, the execute permission. So typing plus is equivalent to typing in the whole thing in the double quote. Minus, you can define another minus. You can alias 111 to CD corner 111, and then if you type in 111, it's equivalent to typing in CD corner 111. So it's just shortcut. And also you can say aliases, which tells you. So it's a permission denied, but usually it tells you all the aliases you defined in your system. So on most Unix machines, if you put alias commands in your .chrc file, you can use them every time you log in. So /chrc is a C shell configuration file. So if you use C shell, then every time you log in, this file will be read. So if you place the alias command in it, then the aliases will be available to you after you log in. Of course, if you use the Bourne shell or some other shell, then you have some other configuration file. So standard input. So every time you log in or run a shell, you are connected to the computer on its particular terminal. So if you type in who, it tells you which users are connected. And suppose Horner is the user who was connected from this machine CSNT1 on this terminal, PTS/3. PTS, I think it stands for plain terminal service. It's an old terminology. So, or another connection from CSC 096 to the other terminal, PTS/0. So these devices are actually files in the directory /dev. As I said, the files in /dev are not regular files. These are really devices, including displays, terminals, printers, etc. So if you log on this terminal, you can see date redirection to this terminal. This is a file, but it's actually your display. So normally, if you say date redirection to a file, you don't see anything because the information goes to a file. But here, this guy is a special file. It's actually your display. So you actually see the output from date command on your display. So if I do a who, I see many users. Let's see, just see myself. You can see that I have 3 terminals open. I have 2 open on my own machine in my office from CSC 660, which is my machine. On these 2 terminals, I have another terminal, which is this one, connected from this machine, CR2306, with this terminal name, PTS/31. So actually, if I open a new terminal and I do the same command, I see I have another terminal connected, PTS/20 and PTS/31, all from CR2306. So if I type in date, I get the date back. If you type in date, PTS31, def PTS31. So I get back this string because PTS31 is exactly this terminal. But if I type in PTS20, I get nothing because it's redirected to the other terminal, but I can see it on the other terminal. So it displays the string here, not this terminal. I can also put it in def PTS2. Now my home computer in my office gets this command output. What about if I try to give it to some other guy's terminal? Then it'll tell me permission you don't have the permission. Otherwise, it'll be trouble, right? You can redirect anything to other guys' terminals. So, right, you can redirect SCD out, standard output, to a different device if you have permission. You can also have write command. Write command is this primitive chat command. you can use to chat between different users. And you can find out which terminal a particular shell is connected to using the TTY command. So TTY stands for teletype writer. Teletype is this old term for typing in something that goes to a remote computer. So you can see TTY. So this means that this particular terminal is PTS-31, and this particular terminal is PTS-20. And you can echo and redirect to another terminal. So, last slide. So, T is this command for T joint in plumbing. What is a T joint? It is like a side branch that's you're placing in a plumbing system to draw some current, draw some water from the main branch. So here's the command who. You see these two terminal sections. You say who sort. So let's see. If you do who, you get all the sessions. If you say who pipe to sort, you get the sorted version of the users. So if you say who sort, who pipe to sort, and then redirect T sorted who, and then type the word count. Let's count how many lines are there in the file. You get 34 lines in the file. At the same time, the sorted tool contains all the information output from the sort. So this command is necessary because you may think perhaps you can redirect with the greater than command. Then it will be wrong because it says ambiguous output redirect, because you're trying to place the output of sort into the file. At the same time, you're trying to use pipe to feed it into the next command. Remember, there can only be one redirection, right? Only redirect the output either to a file or to another command with redirect or pipe. So, but if you use T, then it's okay. T is this side connection where you're piping the output from sort into the input of word count WC. At the same time, you're drawing another connection and placing it into a sorted who. That is, you're creating two branches from the stream. One going to the file, one going to the next command. So that's the use of T. It allows you to create a duplicate connection to the same stream. So the output of sort is placed in the file and piped to WC-L, which counts number of lines, which cannot be accomplished without the T. Okay, see you next time.